Welcome back to Advent of Code 2017, day 3, Spiral Memory. You come across an experimental new kind of memory stored on an infinite two-dimensional grid. Each square on the grid is allocated in a spiral pattern starting at the location marked 1 and then counting up while spiraling outward. For example, the first few squares are allocated like this. 1, 2, 3, 4, 5, 6, 7 goes around the loop like this. While this is very space efficient, no squares are skipped. Requested data must be carried back to square 1, the location of the only access port for this memory system, by programs that can only move up, down, left, or right. They always take the shortest path, Manhattan distance, between the location of the data and square 1. Okay, for example, 1 is carried in 0 steps, since it's the access port. Data from 12 carried in 3 steps. You go down, left, left, down. Okay, from here, down, left, left. Okay. And then 23, 2 steps, up twice, and so on. 1024 is 31 steps. How many steps are required to carry the data from the square identified in your puzzle input all the way to the access port? So we can get this puzzle input, or maybe we can just start with this example. And then we can, oops. This, then we just have to map. I wonder if I still have the directions. Yeah, the directions are up, down, left, right. And then I have point x, y. So I can start with zero, 0. And then I can go, I think I have to map the spiral. So I go right, up, left, left, down, right once, up once, left 2, down 2, right 3, up 3, left 4, down 4. Okay, so I go 1, 2, n. For each, I want to go 1, 1. Actually, doesn't matter in which way I do it. End up the same. Or does it? Oh, it has to be right up. Let's just do right up and then down, and left down. Um, Let's see if the directions are ordered. So if this is up, the first one is right. And then I want to go up. Up is minus, kind of. Then I go down, and then I go, no, then I go left, and then I go down. So right is positive in y, up is negative in x, left is negative in y, and down is positive in x. Okay, so then I go like a current counter. Well, 0. I want to go right, which is the of c. I also want to keep track of this, though, this number. Go in that direction, then and n can be input dot to int. So I go 1 to 1024 or whatever. And I just figure out which point I will be at in the grid. And then I can easily get the distance. So I go the direction initially once. Okay, and if I model 2 equals 0 or equals 1, then I increase C. Well, C is my pointer where I go. Let's make a different one. Current direction. Okay, no, I don't even need a pointer. I can just do imod 4. So I go the first. Okay, I do need to start at 0 then. I start with 0 here, and I go the first direction. Then I check if this is 1. I would update C, which is the amount of times I go in that direction. I don't know if that works. Then I can make a function and take this, return this, p of this dot x times c, this dot y times c. So I go like c times in that direction. Cool. Let's see what happens. 31 steps. We're not quite right. Let's see what happens actually here. Let's only go 10 times. So I go 0, 0. Okay, that's already wrong. Okay, I should start with 1. I go 1, and I go 1 again, and then I update distances. I can't see. So the first one is y1, then -1, yeah. Then I go 2 here, okay, and so on. Then I go I go 1 step, then I go 2 steps, then I go 3 steps. Okay, so that's better. Let's now go to the destination. Hmm. Oh, I'm always jumping ahead. I go here to 3, then I go here's 4. That's not right. I just have to go not faster in one direction, but longer. So I need something else. I actually go always just one step. This is the trick here. I think I can do some kind of counting. So I go I'm already counting the right times, how often I go. I think I'm counting at the wrong time. Let's check again. So um, the direction is currently I'm at 4, but that's wrong. I want to go once. How do I do it? I need some kind of counter. And if D equals C, I reset it. Oh yeah. Something like this. Okay, now I'm going twice in one direction. That's not quite correct. And I have to go all times until D reaches C. I have to go in that direction. Then I update the direction. Maybe this can be another name. And the direction is actually picked differently. Direction is picked. yeah, direction is 0. And then I always +1, d +1, mod 4, like this. That's the direction. So all of the rest is just counting. Okay, what happens at the beginning? Okay, we go to 1 and x is 0. Then we go up. Then we go up twice, so almost there, but not quite. Let's just check x, xx, c, c, d, d. Beginning, x is 0, c is 1, and d is 0. Then, and I end up here. Then it's kind of like this, and then I go somewhere. Yeah, I think that should make it more clear. I start at 0, I have these, which makes me go to y1, and I update c to 2. Because I update x to 1, and c is 2. And the direction changes. And x gets set to 0 again. And then x grows to 2. Then it goes to 3, and then it goes to 4. So it's not quite right. I want to grow it to see the number of steps. X is the number of steps. Then set to 0. Okay, then we just change direction. And then when it's 2 time steps, we also change direction. And we set it to 0. And we increase the steps. So that way we manage to go once here, once up, Then we increase steps to 2. Then we have start going left, left. Then we go down, down. Then we increase steps to 3. Okay, so let's see what we get. Minus 16, minus 16. I get 32. Okay, let's try a simple example. 1. 1 is 1. Okay, 1 is 1, so that's the problem. Should be 0. We can start at 1. Let's just include 1. Because we're actually not using it, so it's already 1 to here. And we're walking in the direction. Why is 1? Ah, okay, I'm stupid. I'm starting at 0 and they're starting at 1. So I can do like this. And then I get 0. Then I get 12. There's 3, 24 is 13. I can do this by getting the absolute value of x and y and adding them. So I get 31. And then I can get my number. And that's correct. As a stress test on the system, the program here clear the grid, and then store the value 1 in square 1. Then, in the same allocation order as shown above, they store the sum of the values in all adjacent squares. So the first few squares values are chosen as follows. 1 has 1, 2 has 1 and also stores 1. 3 has both the above squares as neighbors. So 1, 1. Okay. What's the first value that's larger than the puzzle input? So we just have to map the whole grid. Instead of just walking through, we can save it all. Point. Just make a point has a p and a value. And then we can just store it. And v get value from cur and grid. Get value from point, the grid, which is list of points. And then we just do the summing operation where we have all directions now, also diagonal. So we go -1, 1. Maybe it's easier to do -1, -1, 0, -1, 0, 1. No, 1, -1. And then we do and then we do 0, 0, 0. -1, -1. No, we already had that. -1, 1. Then we have the 1, 1 on the y. We again go 0. Okay, so we have -1, 0, 1, -1, 0, 1, -1, 0, 1, -1, -1, 0, 1, 1. Okay, that's all the directions. There's dot for each. We check grid first or null where p equals p dot plus it order. Not null. Options. For each option we go we just sum if options is empty, turn 0. I mean, it doesn't happen really. Some of this we don't really need to do. We can do mapping. I mean, I wonder if this actually just works. This. Okay, and we can just run it. Well, let's run the tests. 1, 0. Okay, it's already wrong. I should probably start with adding my start point of start and 1. And then, well, I should also print the result maybe. One. 2 has oh, I didn't go further down. The input is 1. So if I go 2, have 1. And 3 should have 2. Okay. 5 has 5. Okay. 1024 has a very large number, so it's smaller than that. Oh, it goes really fast. I will just results equals and collect the results. A pair of I and V. First, and then I can print all of them. 60 has this number, which is greater than my number. So I can put here 60. Okay, that's wrong. What is the first value written that is larger than the possible input? I don't care about this. I just care about this value. Let's wait 50 seconds. Wait 16 seconds. Okay, and we're done. So, spiral memory, what do? We notice that we always go twice for the same amount of steps. So we go one direction and we change direction. We go one step Then we go one step again. Then we change direction. Then we go 2 steps, change direction, 2 steps, change direction, 3 steps, 3 steps, 4 steps, 4 steps. So that's what we have to encode. So I use steps, x, and direction. Steps is the amount of direction, the amount of times I want to go into one direction. D is the direction, and X is kind of like a counter that I do this funky counting with, which goes 1, 1, 2, 2, 3, 3. Well, it's kind of like 1, 1, 2, no, 1, 1, 2, 2, 3, 2, 2, 3, 3, 3, 3, 3, 3, 4, 4, 4. That's what it does. So we just increase every time X. If we reach the amount of steps that I want to go in one direction, I change the direction. If we reach the amount of 2 times the steps, then I reset X and increase steps, the amount of steps I want to take. That's kind of like steps goal, steps taken, direction. Yeah, so that's how we do it. Then we just go in the direction, which is cur plus dirs. Current is a point which has 0, 0 coordinates. Directions is a list of directions which has a few points that kind of go into the different directions. And then I have this operator function plus, which just adds x plus x, y plus y. So I can do plus to go in a direction, update the current position. And that's it for the first part, where I just at the end check what's the absolute distance between x and y of my current position, because that's the Manhattan distance. So that's how you calculate the Manhattan distance, with the absolute value of the chords. The second part, we want to know what's the first value that is higher than my input. If I go and walk the same way, but I always add all the surrounding fields into my field as a number. So the number is not 1, 2, 3, 4, but it's 1, 1, 2, 4, 5, 10, 11, and so on. So I have to simulate adding this number, which is pretty easy because I can just make a grid with points. And points have a position and a value. So the first value is 1. And then this consecutive values I get by calculating the values. And then I go into alters, all directions, also diagonal. Similar to earlier, I map the direction. I can add my current point to the direction to get the field that I'm interested in. And I check in a grid if this field exists. Is there a field with its point being the same as the point added to the direction? Then I take it, otherwise it's null. And I just sum off the values of all those points. And so at the end, I have the list of all of those that are greater than my input number. And I can sort the list and get the first one, which is this one. And that's it. Enjoy the rest of the day.